Hi everyone, welcome back to my channel. Today I am going to show you how to implement the repository pattern with a minimal API in .NET 9. If you're new to my channel, don't forget to subscribe and hit the bell icon to stay updated on .NET tutorials. Let's get started. First off, what is the repository pattern? The repository pattern acts as an abstraction layer between your application logic and the underlying data access layer. Think of it as a middleman that handles all the interactions with your database, whether it's fetching data, creating new records, or updating existing ones. In this video, we'll start by creating a simple minimal API in .NET 9 using Entity Framework Core with a SQLite database, initially without the repository pattern. After that, we'll implement the repository pattern to see the difference it makes. I have created a .NET 9 minimal web API project. First, I am going to clean up program.cs. Alright, now let's define our product entity. First thing we'll do is create a new folder called Entities to keep things organized. Alright, now let's go ahead and add the product entity class. Inside the Entities folder, we'll create a class called Product, where we'll set up the properties for our product. Now, let's define the properties for our product. We'll start with an ID as a GUID, which will be the unique identifier for each product. Then, adding name and description, both are string, and set them to an empty string by default. Adding quantity property to track how many items we have in stock, and a price to store the cost of the product. Next, we'll create the DB-Context. To do that, we'll add a new folder called Data. Before we create the ProductDbContext, we need to make sure we have the necessary NuGet packages for Entity Framework Core. Let's go ahead and add those first. Now, to add the EF Core packages, type EF Core in the search box. First, we're going to install the Microsoft.Entity Framework Core package. Next, we'll install the Microsoft.Entity Framework Core SQLite package since we're going to use SQLite as our database. Next, let's add the DB-Context to our project. Inside the Data folder, create a new class called ProductDbContext, and mark this class as sealed. Now, let's have this class inherit from DB-Context. Here, we can use a primary constructor, which takes a parameter. This parameter will be the DB-Context options for our ProductDbContext, and we'll call it options. And pass options to DB-Context. Now we need to add a product DB set. This DB set will represent a table in our database. Next, we need to set up the database connection string. To do that, we'll configure it in the appsettings.json file. Name database as ProductDB. Let's add the CRUD Endpoints to the project. To do that, we'll create a new folder called Endpoints. Now, let's add a new static class called ProductEndpoints. Next, let's create a new extension method called mapProductEndpoints to map our endpoints. Now, let's use the mapGroup function to group the product endpoints together. Here I'm going to implement the first minimal API, a get endpoint to fetch all products. The getAllProducts endpoint takes two parameters, the ProductDbContext to access the database, return an OK response with the list of products, indicating that the request was successful. Next, let's implement the getProductById endpoint to fetch a product by its ID. To save time, I've copied the getAll endpoint as a starting point, and we'll modify it to handle fetching a single product by ID. If the product is null, we'll return a not found response. Otherwise, we'll return the product with an OK response. Now I'm going to create a DTOs folder to organize all our DTOs. Inside the DTOs folder, I'm going to create a record type called createProductRequest for our create endpoint. Now I'm going to create the createProduct endpoint. This will handle adding a new product to the database. For this, we'll use the post method and map it using mapPost. We'll take 3 parameters: a createProductRequest for the product details, the ProductDbContext, and a cancellation token to handle request cancellations. Add the new product to the products table, and finally, we'll call SaveChangesAsync method to save the changes to the database. Once the product is added, we'll return a 201 created response to indicate that the product has been successfully created. Now let's add the updateProduct endpoint to handle updating existing products. I've copied the create endpoint, and now I'll modify the code to handle updating an existing product. For the update endpoint, we'll take 4 parameters: ID as a GUID, the updateProductRequest DTO, the ProductDbContext, and a cancellation token. Copy the createProductRequest and create a new updateProductRequest record, which will be used for the update endpoint. Fetch the product by ID. Check if the product is null. If it is, we'll return a not found response. Update the product's name, description, quantity, and price with the data from the update product request, and then we'll call SaveChangesAsync to save the changes to the database. Finally, return a no content response to indicate the update was successful, but there's no need to return any data. Now I'm going to implement the delete endpoint. I've copied the code from the update endpoint and will modify it for deletion. The delete endpoint takes three parameters: the ID of the product to be deleted, the ProductDbContext, and the cancellation token. This endpoint first fetches the product by its ID. If the product is null, we return a not found response. Otherwise, we delete the product from the database and call SaveChangesAsync to persist the change and return no content response. Before we run the project, we need to register our DB context and the endpoints in the application. Now we need to apply the migration. First, let's add the Entity Framework Core Tools NuGet package. Go to the NuGet Package Manager and search for Microsoft.Entity Framework Core Tools and install it. To create the migration, open the Package Manager console and type the Add Migration command. This will try to build our application and generate a migration file. Now to apply the migration to the database, we'll use the Update Database command in the Package Manager console. If you check the Data folder, you should see the ProductDB SQLite database file. Let's run the application. Now I'm going to test the endpoints using .http file. The .http file editor provides a convenient way to test API projects, all without leaving Visual Studio. You can send requests and view responses directly within the IDE. I've created requests for all the CRUD operations, so we can test creating, reading, updating, and deleting products directly from the .http file. Let's start by testing the getAllProducts endpoint. The get method is working perfectly. We can see the two products that I created earlier in the response. Now let's try the post request. I'm going to change the product name, quantity, and price, and then we'll send a request to create a new product. The response we get is a 201 created status, and the newly created product is included in the response. When we run the getAllProducts endpoint, we can see three products in the response, one of which is the newly created product. Let's now try the update endpoint. The response we get is a 204 no content, indicating that the update was successful, but there's no additional data to return. Let's try the delete endpoint. The delete endpoint returns a 204 no content response, indicating that the product was successfully deleted. Now I'm going to implement the repository pattern and refactor the endpoints accordingly. First, let's add a new folder called Repositories to organize our repository classes. Next, I'll add the iProduct repository interface, which will define the CRUD operations for our products. Let's start by adding the add method to the iProduct repository interface. This will define how we add a new product to the repository. This method will take two parameters: the product to be added and the cancellation token to handle request cancellations. Next, we'll add the updateAsync method, which will take two parameters: the product to be updated and the cancellation token. The deleteAsync method, which will take two parameters: the product to be deleted and the cancellation token. Next, we'll add the getProductByIdAsync method, which will take two parameters: the ID of the product and the cancellation token. It will return the product if found, or null if the product doesn't exist. Lastly, we'll add the getAllAsync method, which will return a list of products. Now I'm going to implement the product repository class, which will implement the iProduct repository interface and define the logic for each of the CRUD methods. Let's move the product repository class to a different file. First, we'll inject the ProductDbContext into the product repository class so we can access the database. Next, let's implement the addAsync method. This method will add a new product to the database, using the ProductDbContext to save the changes. Let's quickly implement the other methods now. We'll start with deleteAsync, followed by getAllAsync, getProductByIdAsync, and finally updateAsync. Now let's register the iProduct repository and product repository in the dependency injection container in program.cs so they can be injected into our endpoints and used throughout the application. Now let's refactor the endpoints by injecting the iProduct repository instead of the ProductDbContext. This will allow us to interact with the database through the repository, keeping our code cleaner and more maintainable. Move quickly and refactor the remaining endpoints to use the repository methods instead of the ProductDbContext. This will ensure consistency across the application. Remove unnecessary using. Run the application again. Now let's test the getAllProducts endpoint to make sure everything is working after the refactor. Now let's test the getProductById endpoint. And there you have it. We've successfully implemented the repository pattern using a minimal API in .NET 9. This approach helps keep your data access logic clean and maintainable. If you found this video helpful, don't forget to give it a thumbs up and share it with your fellow developers. And if you have any questions or suggestions for future videos, leave them in the comments below. Until next time, happy coding!